number 6 is giving us 5 tables, and hopefully you notice that these are not domain and range tables. They don't have 2 rows per table. This is showing us something entirely different. So let's read it very carefully. The tables show the second consecutive differences for 4 different functions. And you may be thinking, but there are 5 choices. Which table corresponds to a function that is neither linear nor quadratic? So 4 of these tables represent linear or quadratic functions. And then one of them is the weird one, the one that we have to find. Now, if I just had to take a stab in the dark here, I would go with C. Because if you look at these, this is common, but that B is tricky. You got to know something there. This is common and this is common. So if, and they're talking about functions, so that commonality is important. So if you just had to take a stab in the dark, let's say you're on the high set and you have 20 seconds left and this is the last question, you can guess the right one if you know about common consecutive differences. So C is the answer, but I want you to know why it's the answer. So in this first choice, A, let me just write out what it's saying. The consecutive difference at the second level is common. Now, I know that that means I'm dealing with a quadratic equation, except for one situation, and that's B. Let's jump down here at D, because this example or this answer also explains D and E. Whoa, sorry, I didn't mean to do that. Let's try that again. And it's not going to let me. It's going to make me write that again. Okay, D, the common consecutive difference at the second level, or the difference at the second level is common. That is a quadratic. And then the same is true here. The difference at the second level is common. So this is quadratic. So those 3 are quadratic equations. C is the oddball. But here's the real thing that I wanted you to know about B. And it's this fact. I'm really more interested in that than the answer C here. When consecutive differences, let me say common consecutive differences, are 0, the function is linear. And think about that last problem that we just did. That's why they put that one in there. Because a linear function is a straight line. This B table has no slope. There's nothing, there's no steepness. So anytime you're seeing zeros like that, it is a function, but it's linear. It's not quadratic. But the question is, which one of these is neither linear nor quadratic? And that is C. I suspect that C might be an exponential function, but I don't know that. But I can tell you, because those values are not the same, that it is not linear or quadratic.